Welcome, everyone. Happy Wednesday afternoon. Thank you for taking time out to join us today. I'm Sandy Blair, one of the architects here and VP of Business Development here at Marx Okubo. I have the privilege today of moderating our panel discussion. I think we're all in for a real treat. I've learned so much over these last few months.
Romantic.
I was saying I've learned so much from this panel discussion over these last few months. So we have lots of best practices and lessons learned to share with you all from our collective set of projects. And we boiled them down to 7 themes, and we'll sum it up at the end. Quick shout out to those that traveled here today, and for our landlord, Cahill, and our property manager, JLL, for allowing us to host in this space, this beautiful space, and to the many Marx Okubo staff that helped put this together. 2 special shout outs, one to Danny Rodello here, who kept me organized throughout this process. She's running the slideshow today. And my friend Francis, who's our audio tech, making us sound really professional today. All right, let me introduce the panelists. First, Carolyn Bookhart was appointed Director of Real Estate Development of RCD in April of 2014, and has over 20 years of experience in the development of affordable housing. Her primary responsibilities are to ensure an active pipeline of new development activity and to oversee and manage staff performance at all RCD housing developments. Under her direction, RCD has completed 13 projects comprising 771 new and renovated homes, with 1,400 more in pre-development or in construction. Randall Thompson is Senior Pre-Construction Manager at the newly formed Nibby Prefab division of Nibby Brothers General Contractors. With over 20 years of construction industry experience, Randall excels at merging modern methods of construction with tried and true practices. His leadership at Nibby Prefab further demonstrates his dedication to advancing the construction sector through innovations in industrialized construction. Chelsea Jenick is the Bay Area Regional Director for Woodworks, a nonprofit organization. Chelsea helps project teams achieve successful wood buildings. Prior to joining Woodworks, Chelsea spent a decade in structural design consulting. Her experience is in a variety of sectors, including residential, higher education, and retrofit of existing and historic structures. We've reached out to Woodworks many times over the years, and they truly are a great resource. Jonas Weber, AIA, is an associate at David Baker Architects and leads their modular design studio. He has overseen work on an impressive 15 modular projects, 7 of which have been built to date, with over 2,200 modular living units that was designed under DEA. Jonas recently completed Tahana Supportive Housing, a high-density modular development in San Francisco that provides 145 permanent supportive studios for the formerly unhoused. This is his 3rd modular panel discussion this year, so we're very grateful for his time. And our very own Tommy Fong. Tommy is a member of our executive leadership team and oversees the providing leadership to shape, guide, and implement the organization's technical agenda. Prior to his current role, he served as Assistant Vice President for our Northern California region, and he has been with Marx Okubo since our San Francisco office was established 25 years ago. He is our resident expert on modular. So a round of applause, please, for our panelists. Thank you for your willingness to do this panel with me, and so gracious with your time over these last few months. All right, I asked ChatGPT to try and do a Venn diagram of how the 5 organizations have worked together, and it didn't quite work out. It turned into a big blob, so you'll have to settle for a little blurb on each company. But I thought to get our creative juices going this afternoon, I would ask an icebreaker question. If y'all had 25 hours in a day, how would you spend that extra time? Carolyn, why don't you start us off?
I would spend it doing yoga and meditation.
Awesome.
Definitely more time outdoors, more time with the family during the week. Also getting some more exercise, spend more time at the desk, that'd be great.
Nice. Tommy?
I spend it with my kids. Don't have
What a
time
good
to
dad.
debate.
What a good dad. Chelsea?
I think time outside for sure. More fresh air.
Okay. Two outdoorsy people. Okay. Jonas?
I'm with the self-care group. So that's the one thing that before kids get sacrificed, it's self-care. So.
Awesome. I would say sleep with a close second of eating something. Danny, what would you?
I would definitely sleep.
Yeah. And then to get some audience participation, let's do a quick round of this or that. So I'll say one word and then a second word, and you raise your hand if you align with one or the other. All right. Dogs or cats? Dogs? Cats? Okay. Text or a phone call? My husband will say text. Text? Two hands. Phone call? Oh, okay. Coffee or tea? Coffee. Carolyn, you're drinking tea. All right, tea? Okay. Morning person or night owl? Morning person. Night owl? Yeah. Sports game or a concert? Sports game. Concert? Yeah. Oh, nice. Cookies or chips? Don't worry, we have both downstairs. Cookies? Chips? Zoom or Teams? Controversial.
Text message.
Zoom? Back to text message. Teams? Oh, pretty even. All right, and the highly controversial, Android or iPhone? Android. iPhone? Oh my goodness. All right, thanks for indulging me. Here's our agenda. Before we talk about the agenda, quick poll of the audience. Developers in the room? Great. Architects, engineers? Nice. Contractors? Brokers? Well, some brokers on the list. Anyone else that I missed a group? The city? Thank you, Ali, for representing the city. Awesome. All right, so why are we here? Lawyers, I'm sorry, Aaron, attorney. Representing, thank you. So why are we here? Why did we put this panel discussion together? There's a lot of hype around modular construction. We at Marx Okubo get asked quite a bit what our thoughts are, who we like, what factories we like. Is the savings, cost and schedule savings really what people talk about? And so the idea for today is, can we have an open discussion and share our best practices and lessons learned to really get modular going? Randall and I were just talking last week, each architect, developer, contractor is learning on their respective modular projects, but really learning what works and what doesn't work and saving it to apply to their next project, right? Pretty typical. But we want to change that today by sharing it with the industry. What if we came together and share this info with each other openly, and we collectively learn as an industry and make bigger leaps forward? So that's the idea. We put this together, and I'll ask Randall and Chelsea to talk about this. Chelsea first.
Yeah, so on the why are we doing something different? I think the construction industry is slow to change. You know, we know how to do things, we like the way things have been done. But when we site build buildings, each building is its own prototype. Like we're doing it for the first time. We're bringing materials to site and we're building it like it's the first time we've done it. So off-site construction is starting to engage manufacturing and prefabrication. So we're doing some of this construction off-site and we're saving cost. That's the big thing, is cost savings. How can we do that? And a big part of that is time savings. Time is money. So really moving some of that construction that's typically done on-site, off-site to save cost, materials, labor is the intent here.
And then adding to the schedule savings would be the fact that you are building your project concurrent activities. You got work that's happening on site while you have work that's happening off site. That's a big part of where the time savings comes in. But in order for that to be successful, that requires a great deal of planning and coordination happening earlier in the overall project life cycle. So during design and during pre-construction, which we'll talk about today, some important activities that need to happen during those phases to realize these time savings.
Yeah, thanks. So could modular construction be the solution to our housing crisis? We hear that a lot. Could this bring about the much needed housing online faster? And the idea of prefab and modular has been around really since the 19th century. Think of the company towns built in the middle of nowhere to support an industry. And modular, as we know it, has been around for decades, but it still really feels like it's in its early stages. So whether you're working on multifamily residential, student housing, or even exploring steel modular, the lessons here can be applied. We'll have a break in the middle for Q&A and more time at the end, so I would ask that you hold your questions. We will finish at 4 o'clock, and if you don't get your questions answered, join me downstairs at the reception. The panelists will be there, and you can meet them. So a reminder, our focus today is on wood frame volumetric modular construction. The discussion is through the lens of affordable housing development, timely since May is Affordable Housing Month. Carolyn, Jonas, and Randall recently completed single court apartments last fall, and we'll talk about that as a case study today. And before we do, Chelsea, can you start us off and talk about prefab as a broader subject?
Yes, definitely. Thank you, Sandy. Excited to be here. Thanks for having me. So prefabrication, what do we mean when we say that? So I'm just going to talk about some terminology here. So the idea of prefabrication is, taking some of this construction that's typically done on-site, moving it off-site. So we can have that repetitive process. We're now building in a safer work environment. It's controlled, has higher quality and consistency. And it reduces on-site construction risks. So things are coming to site, so you have that shorter construction schedule. We have then less chance of weather delays and weather issues. Fire, I know construction site fire is a big consideration, particularly with light frame site build. Modular comes to site with that fireproofing already there. That chipboard is installed. So we're really reducing that risk. And we're manufacturing. So different types, some terminology that I'd like to introduce here before we jump into volumetric modular. So panelized construction. Panelized construction is where those walls or floors and roofs that we do are done off-site. So typically, as shown in the photo there, it's really the floor or the wall framing and sheathing. When it's done this way, also known as flat pack panelized, you can still do all the inspections on site. So it's the same permitting process. We're just now bringing some of the pieces together, already partially put together. When we do the floors, we also call them floor cassettes, roof cassettes. And you'll see here in this photo, so this is flat pack. So shipping is a consideration here. We'll hear about that more from the panelists in terms of modular. But with panelized, it's flat pack. So all those pieces stack very efficiently on a truck. And so you're limited on your truck bed. Another type of panelized construction that is kind of seen as a new and exciting one, mass timber. So mass timber, we're now taking our commodity lumber products, so our 2x material, and we're laminating it together to make larger pieces of wood. So that can be glue lam, such as the beams and columns shown in the photo, or cross-laminated timber, also referred to as CLT. I think this has gotten a lot of buzz recently, but it's been in the code for a bit. So glue lam's been in the code for a while, and we use it in light frame construction. CLT's been in the code for a bit, but what is new and exciting is the tall timber. So now we can go up to 18 stories with mass timber. So new options that all fit under this umbrella of prefabrication.
Yeah, Caroline, when it comes to like CLT, we recently worked on a project. It's actually the first CLT project in San Francisco. It's called One Naharo. It's a 4-story office building, finished a couple of years ago. And CLT definitely has a place, just like Modular does, in kind of moving forward. And CLT actually shares a lot of kind of traits in common with Modular. And some of those things are like, for example, early planning, early coordination, identifying the fabricators that can build these products. A lot of times they're not local, and a lot of times they require early upfront deposits. And a lot of that needs to be considered early on in the process, much earlier than you would have to consider it for a state-built project. But CLT and Modular both have benefits too. There's a lot less construction on site, a lot less waste, a lot more efficient projects. And in the case of CLT, obviously it's very attractive, and it's a great environment, has great environmental benefits.
The photo on the right is Wendaharo, right?
Yes.
So we can prefab a lot of different things. So we can prefab plumbing assemblies, bathroom modules, classrooms. I've seen some mass timber classrooms also prefabricated. And prefab exterior wall panels. These are becoming popular, particularly with mass timber, to protect it soon from the weather. And we've seen, mobile homes for a long time. So there's a lot of different varieties within prefab. But what we're talking about today is what we refer to as volumetric modular. So you can see now, compared to flat pack, we are now shipping a volume to site. And that volume contains a lot more than just the wood framing. It contains your finishes. It contains a lot of different items. We want to think about what types of occupancies make sense for modular. We want repetitive unit types. So hotel rooms, apartments, condos, affordable workforce housing, student housing, all are good candidates. So we'll hear a lot about this today from our other panelists, but there's a lot of differences from site-built and panelized even in terms of shipping and erection, as well as permitting and inspection. So these are big considerations when getting into modular. All that does occur off-site and how that is regulated. And what all is included in these modules. We can have our bathrooms, we can have our kitchens, we can even have furniture in them sometimes. So there's a lot of options here that can be included in these modules.
Great, thanks, Chelsea. Alan, take us through.
Good afternoon, everyone. And happy to be part of this panel. I really think that, modular does offer some good opportunities for us in our shared industry. And I think it's just kind of another tool that can be in our toolbox. So I think it's really great to kind of share all the lessons learned that we can and share together so that we can kind of grow in this space. So I'm going to be talking from, kind of the owner-developer perspective. And, but even if you aren't an owner or developer, I think it's helpful to just kind of understand, a number of the considerations for choosing modular as a developer, what some of the risks are and things like that, so that as a team, we can all kind of work together and kind of navigating through the process and anticipating risks and things like that, so we can all be successful. So, Chelsea talked a little bit about sort of why, and I know with, RCD, we were really struggling with just kind of the, skyrocketing, spiraling costs and timelines for building affordable housing. So, we were seeing the timelines going from 15 to 16 months to now, 20 to 24 months is fairly standard. We've had many years of 5 to 10% escalation in hard costs year after year. And so we really got to the point where we felt like we just needed to try something different and try some new technology, innovate a little bit, and just see if, we can find a new way to do things to try to contain some of these costs, because it just felt really unsustainable, still kind of feels unsustainable. So that, that's kind of the obvious thing, time and cost. A couple of other points that I think are worth mentioning that Chelsea touched on is modular really expands employment opportunities in the construction industry. So because the facilities are indoors and climate controlled, a lot of the workstations are ergonomically designed. It really opens up a lot of opportunities for folks to work in the construction industry that might not otherwise be able to access these jobs, in the field. So that helps to diversify the labor pool and also increase the supply of labor, which then also helps cost and timeline. So that's an important, benefit of modular. And then also, as mentioned, there's a lot of real risk, especially in the urban areas around arson and fire and theft and things like that. And so being able to take, a good chunk of the construction off-site, that helps to mitigate that impact or that risk. And similarly with neighborhood impact, construction is noisy and there's trucks and equipment. And so being able to shorten that effect or that sort of imposition on a neighborhood is really helpful too. So I think that's good to point out because there's certainly risk with modular that need to be considered and sort of mitigated around, but there's some things where you might reduce risk from a standard construction process. So it's a little bit of, just sort of determining different risks and strategizing on how to work through those and be successful. So as Sandy mentioned, we all worked on development together. So we're going to use that as a case study to just kind of offer some specifics that we worked through, and then also just as kind of a launching off point to talk more about our different experiences. So this is a project in the city of Milpitas. We finished up end of last summer, started leasing up in September. It's 102 units, so it's a good size building, and I do want to note that it's studio through 3-bedroom units. So I think most folks, understand that, the most efficient way to do modular is kind of 100% studio units. So PSH buildings, for example, permanent supportive housing, are great candidates. But this is a good example of how you can be successful, you can gain the benefits from modular with a family building or with, the variety of unit types if it's sort of thought about thoughtfully and sort of planned for from the beginning. So this is a good kind of alternative example from the studio buildings. 100% affordable, so we did have all the kind of affordable financing challenges that do interplay with how modular works. And again, it was RCD, David Baker Architects, Navy Brothers, and Autoball was our manufacturing company out of Idaho that we worked with. So, and at the end of the day, there were some real benefits in cost and time. So what I did was, compare Sango Court to other projects that we had in our pipeline, similar building types, podium-style buildings that were in construction right around the same time. And we saw about a 5 or 6% cost savings. So construction contract was about 60 million or so. So a pretty meaningful amount of hard cost savings. And then on the time factor, we actually saved about 25% in the schedule compared to comparable buildings that were in construction then and still current construction a lot faster. So we really did see some real impact on the time. And of course, there's some challenges and lessons learned, which, I can go through that if you plan ahead and kind of work around mitigating those things, I think you can be successful. I feel like Sango was successful at the end of the day. Next slide. So the first thing that RCD did, I'd recommend anyone to do this if you haven't done modular before, is just do a lot of research to understand it. We talked with peers of ours who had done this work before, designers, contractors. We went and toured manufacturing facilities, talked to lenders and investors and so forth to really get our arms around, how it works, what are the issues, how to plan for those things. And we also had to, get our board and our executive level staff on board with the decision to move into modular. And so it was helpful to be able to kind of get them feeling comfortable that we kind of know mostly what we're doing and that we understand the risk and we're prepared to handle that to move forward. So that's a good way to approach it. And then the other thing, once you sort of, got your arms around the modular strategy, then thinking through kind of what's a good project to fit, good fit for a project, because some are better fits than others. So that would be something where you might talk with your contractor about, site logistics, and is it going to be, for example, if a site is, really crowded streets and lots of overhead utilities, it might be more challenging and create, sort of additional complications that might make it not quite so worthwhile to pursue as a modular deal. Project size is also something to think about. I mean, I think you can do modular probably in most any size, but if you really want to start to get the economies of scale and really maximize the benefits, what I've heard as a rule of thumb is kind of 80 units and up is where you're going to start to really see that impact. And also, I think everyone will tell you that you want to start early in design. So early in schematics is when you really want to be planning for and designing for modular. Jonas, I know we'll talk more about this, but you really have to design a layout and the units specifically to work for the modular sort of assembly line system. And so you want to do that early on. If you sort of well into your design development process, you'll likely have to spend a lot of time and money to redesign the project, maybe get updated entitlements and things like that. So better to start off in the beginning if you can. And then of course, if you can get a team together that has good experience, that's going to help you navigate through the process.
I think adding to that, just to highlight the importance of building your team early on. Usually the rule of thumb we give is if you're going to consider modular and the site makes sense for it, make that part of your design, even if you're not 100% certain, because you can always have an opportunity to pivot to go to a conventional build. You'll end up with an officially designed building. It's much harder to go in reverse. Some people we've seen projects where they treat modular almost like a VE, and they've designed it conventionally and say, hey, we think this could work, the massing makes sense. And then they want us to go backwards, and it can actually be a little more disruptive if you start off in a conventional building. And the other part that I would add is that do your homework, get out there, get to know. You'll find within the industry there's a lot of us that are very willing to share our experiences, the good, bad, and the ugly. Many of us are still learning, but this was actually our first modular project, was RCD's first, and we all kind of learned it together. We did our homework, and we found a lot of great people in the industry that help us be successful by sharing their experiences. So can't overemphasize enough the benefit of just really doing the homework, getting out there, talk to manufacturers, other developers, architects, and builders. They'll talk to you and they'll help you out. So definitely leverage that resource.
Yeah.
Carolyn, I wanted to ask, since it was NIBI's first project, modular project, how did you vet them? How did you get buy-in from your board, the executive leadership team?
That's a good question. Some of it was we had a good relationship with NIBI. We had a track record with them. They also had staff, like Randall, they had staff that did have experience, senior level staff that did have experience with modular. So that was important for our decision. So then the last piece that I'm going to kind of touch on here is just the key risk areas, which are, big, that everyone should be thinking about, particularly for affordable housing, but I think in general. So one of the biggest kind of challenges with modular is really around the financing. So some of you maybe already know, but for modular, the financing is really different. So with standard construction, you sort of pay for what you've received, right? You might be 30% complete, and so you pay for 30% of that construction work. With modular, it's really like the opposite. So you end up paying, a good chunk up front to reserve just a place in the production line, 6, 8, 10 months in advance. Then you pay another big chunk of funding for them to then order supplies and materials. And then you pay another big chunk of money to start to go through the production, that they'll draw down on the production. And so it's a really different financing model. And so one, you want to make sure that whoever you think are going to be your lenders are comfortable with that kind of manufacturing financing way of doing things, and that they're comfortable with modular construction, because they aren't all comfortable with that. So you do need to kind of think about that up front. The other thing that's, probably applies to all housing development, but especially for affordable housing, is that in order to reserve that place in the production line 6, 8, 10 months in advance, so that when you get your tax credits, you'll have those modules produced when you need them, when have your foundation built, you're ready to receive them. So you put that deposit in, you pay that deposit, which is, maybe several to many hundred thousands of dollars. It's about 5% of the modular contract, which is around, it was 16 million or so was the modular contract, I think, for Sango. So it's a good chunk of money, and you're putting that out before you've gotten your financing committed. And what happened with Sango Court was, when we originally presented this to our board, one of our mitigation strategies was that we were only going to do this, some of you may understand this, that we're only going to do this on 4% tax credit projects, because at the time that was a non-competitive path. So by the time, though, that we got to applying for tax credits, that environment had changed, and it was extremely competitive. And so we put the deposit in, we applied for tax credits, and we didn't get the credits. And I think we maybe applied 2 or 3 times more before we actually got the allocation. So that's the final piece of financing that we need. When you get tax credits, you have a very hard deadline to start construction, 6 months from your award. By that point, our modular partner didn't have availability for us anymore. So they were booked up for the whole year. So we no longer had that partner. So that was a very difficult situation that we worked through. So basically, in the course of 6 months, we had to, all of us, really scramble to find a new company to work with, which fortunately Okubo had space for us. We had to pretty dramatically redesign the project so that it would fit Okubo's specific, system. We had to get an amendment to our planning approvals because we had to change the facade because of those design changes. And because, one benefit of modular is it's a big design build, basically subcontract that locks in that price. Well, because we had to change companies, we had to get a new bid, which was, of course, $2 or+ million higher than our budget. So we had to do a bunch of value engineering, all within 6 months. So that was a tough situation, would not recommend it for anyone.
You called it the catch-22 of TCAC funding.
Exactly. So the lessons learned from that, are, I would say, one is, you certainly want to work with your local pre-development lenders to support that deposit. So, because that is a big risk area, especially if you're a nonprofit. The big thing too is I would say to negotiate as aggressively as possible with your modular company to see if you can minimize that upfront deposit, and also see if there can be some kind of arrangement so that if you don't get your tax credit award, you can push the schedule out 4 months and they'll continue to honor that reservation, which may be difficult, but that's what you want to try to achieve. Then you would also really evaluate how competitive you think you are at that time, and then do kind of a risk assessment. Do you think you're going to be successful? What is your tax credit tiebreaker score? And probably, your escape valve would be to talk with your team and map out, price out, and see if you can switch to stick built at that time. So I think that's the escape valve for that risk right there. And then the last piece I would just like to mention is I think this could be a good advocacy point for folks at the state level through the CIDLAC to, maybe have a set aside or something in the tax credit and CIDLAC competition so that for projects that have modular, so that if they apply, they have more of a guarantee of going forward. So that's an advocacy point. The other kind of big issue is rain. Rain is also unpredictable. So on Sango Court, we actually had this really perfectly lined up schedule where, we got our tax credits, we had a perfectly positioned spot in the production line so that we'd have the modules come out in June, and then we'd have the roof up by September and October. It was perfect. And then we ran into unforeseen conditions in the getting out of the ground, which is not uncommon. So that pushed our project back a couple of months and ended up in the rainy season. So maybe ended up constructing, a pretty well-engineered, framed out temporary roof structure so they could work on putting equipment up and finishing up the roof. But we did still have some rain damage. And so that's something you would want to talk about, like how do we build a temporary roof? What is it going to cost? It was pushing $1 million between the roof and the damage for the rain. So definitely want to have that in your numbers for contingency or an allowance. And then different quality control issues that I know Randall will talk about more that can certainly be managed but are just kind of different for modular than site built. Warranties are a little different. We did find that the warranties for the modules actually start when the modules leave the factory. So by the time people moved in, that 1-year warranty had expired. So that was kind of a surprise for us. So our warranty is still with MIBI, so I feel fairly comfortable with that, but definitely something I know they were thinking about a lot and a question to be asking when you're embarking down this path.
Jonas, you had talked to us about alternative funding sources. You want to talk a little bit about that?
So Carolyn mentioned local pre-development funds and sources for that, and I think that's one that plays a big part in affordable housing projects that are considering modular. In addition to that, we have some experience with the San Francisco Housing Accelerator Fund, which formed in part to sort of study the challenges that you were mentioning, Carolyn, about getting our affordable housing projects through permitting and into construction and delivering those in a timely way, and seeing if there's ways that we can bypass some of the challenges which include with modular projects, which include the payment of a deposit, but also some of the permitting timeline issues that we're seeing in San Francisco and around the Bay Area. And so the San Francisco Housing Accelerator Fund partnered with Mercy Housing and Tipping Point on the Tahoma project that you mentioned. And that it was key to realizing the project in a span of 16 months.
Great. We'll pause here. Anyone have a question or two? Mr. Carolyn? I know we have some affordable housing development, a couple hands up.
My question is,
Okay.
oh, sorry.
No, go ahead.
My question is about how during the design
process you kind of plugged in with the manufacturer. At what point did the manufacturer become involved, and to what extent did they become involved, and then how did that relate to the deposits and payment schedules?
I can speak to some of that, just because it's design now. So we often, as Carolyn mentioned, if a developer is considering modular at all, we encourage the early design to be developed around modular friendly approach, because it's so much easier to, as Randall mentioned, go backward to site build rather than switching from site build to modular later in the process. And so to answer your question about engaging with factories, I think the trend is earlier and earlier in project phases. So even within schematic design, we're seeing engagement with factories, but anywhere from the end of schematic design to the end of design development is when we either engage or contract with a factory through the rest of pre-construction.
Yeah, because each manufacturer, they all have something a little bit different on how they manufacture their product, right? And so you can take design to a point, as Joe's mentioned, maybe related to like DD phase, but maybe you were introducing a design build subcontractor or another trade in the process, or another design discipline in the process. But you want to go so far down the path that you have to go work backwards now to accommodate whatever the nuances of that manufacturer. It could be a dimensional constraint, it could be a structural element of how they actually manufacture the modules themselves in the factory. So getting them involved earlier on allows them to give that feedback. The challenge with that, going back to the deposit conversation, someone might ask, well, why don't you just wait till they pay that deposit until you've got all your funding lined up? There's challenges with that because you do need them involved so much earlier on, and because you're going to start kind of designing your project to some of their standards, you need their engagement quite a bit earlier on. So you couldn't do it another way, but you're going to start losing some of your efficiencies. You're going to pay additional design fees and maybe lose some time by not getting them engaged earlier in the process.
Yeah, speaking as a best practice, it's rule of thumb is you really want to be basically done with the design at the end of DDs. Jonas, you can probably support that argument where you don't want to make a lot of changes at that point, because by then the modular design is done, it's been permitted, and they potentially are starting. And you definitely don't want to make changes while production is happening. Production happens very quickly for most of these modular projects. Another thing I wanted to kind of chime in on that topic is really understanding the scheduling and how the factories work. Factories are literally factories, they're production lines. So unlike conventional construction where, if you want to change something, you can hire another crew, bring another crew on board. supplement your forces. Modular factories don't work that way. Modular starts at one end, it finishes at the other, and so you can't really make a lot of changes midstream. And back to what Carolyn was talking about earlier, you have to get your place in line with that deposit in the factory. Because once your project is done, or if you miss your window, the factory needs to have another project online, because in order for them to be cost effective and save business, they need to be operating at 100% capacity. They can't wait for you to start a project, so they're gonna replace you with somebody else. So that's just something else to keep in mind in terms of this early coordination and planning.
Yeah, for developers, reaching out to factories, developing relationships, and getting a sense of the wide range of preferences that factories will bring to you. For example, on one hand, Autoball and a few other factories, they want to get in and get their hands on a project as early in design as possible because they have, I'll say restrictive, you can take that negatively, but it's actually a good thing when it comes to developing successful modular projects. So they want to get in early, they want to sort of share with you their limited catalog of details and materials and finishes that you can choose from and work with. It's much better to do that early on and develop around those parameters. On the other hand, there are factories that are wide open and you can wait until later in DD, engage with them, do some competitive bidding amongst factories that sort of follow that approach, and it works to the benefit of the project in a different way.
Was there another question in the back? Was there one more?
Hi, Isabel Brown from Gold Farm, and let me represent public agencies and nonprofit developers like Carolyn. Carolyn, on your deal, who held the contract with Autoball? Did RCD or did Unity hold that
That's
contract?
a great question, and I'll say something, and Randall, you can add it, but I think that's important. So everything was, we had a GMP negotiated bid with NITI, and so Autoball was a subcontractor to them. So that was a really great arrangement for the owner, because we really want to have everything in one contract with the GC, and then they manage the subcontract under that.
The initial LOI, the initial commitment with Autoball, with the manufacturer, RCD had held that just initially because they usually use the lender requirements, right? You're not in a position to get into a construction contract yet. So they're usually the first line of commitment with the developer, and then when we get to GMP, then we're issuing a procurement or purchase contract with the manufacturer at that point. We have sole responsibility of managing them, getting the product on site and so on.
And did they have to get a performance bond?
They did, it's a good requirement. With most, if not all, affordable housing requirements, it is a requirement that flows down to manufacturers. So I'll talk a little later about what that does to the pool of manufacturers, but that was a requirement for this project. So yes, they were fully bonded for the value of their contract.
But I will add, though, that NITI provides the payment and performance bond, or the GC provides the payment and performance bond. So you're not necessarily restricted to a manufacturer company that provides that kind of bond. They may provide some other kind of instrument. But as far as the developer and the lender to the developer, the arrangement is pretty standard, really, with a contract with a general contractor, a payment performance bond for 100% of the job. A lot of that all still looks the same.
I know there were some other hands up, so can you hold your questions? Let's continue, and I will answer some more questions along the way. All right, Jonas, take us through the design process.
Okay, thank you, and good afternoon, everyone. Carolyn, it's great to be following up on the things that you were talking about, because you spoke to the early engagement both with the factory and just with the idea of the modular approach. I think those things play into some of our early discussions with developers on how a building may or may not, how a site and a building design may or may not be appropriate for modular construction. There are aspects of sites, whether it's access, whether it's staging zones, which I think Natalie will speak to. But there's also just the layout of the building and how a site may or may not yield the target units, both mix and count. So we're looking at typical unit plans here, and it's worth mentioning that modular factories sort of grew out of, and the successful factories grew out of a focus on a typology that is single room occupancy. And so whether it's workers' barracks or military barracks or hotel rooms, it's all this typology of a single room containing the bathroom, the kitchen space, if there is one, the sleeping space. And that, it was mentioned earlier, the studio unit is the model for that when it comes to housing design. And so that Tahana project that I mentioned is all studio spaces, and it works well for sort of the factory wheelhouse, where every single unit, every single module is exactly the same. You want that repetition as much as possible, and it's the case for all factories that are following this assembly line principle. And once you start to deviate and add complexity to the unit mix or the types of units, you have to be really mindful of what variations you're introducing to the design. And I think what you're seeing is that if there are typical unit plans, different types of units, 1s and 2s, that you're doing your best to follow a repetitive approach to design. You're with the affordable housing projects and those that are following Chapter 11B accessibility standards, there's kind of a limited layout approach to kitchens and bathroom layout. So all of those are hugging the corridor wall, repeated because there's one layout that works best for accessibility standards, and you have this core approach where the core of the unit is repeated, and if there is any kind of architectural expression, it's happening in the last 3 feet of the unit, so the last 3 feet to the exterior wall, or even within the exterior wall assembly itself. And everything else is pretty much standardized, and you'll hear this from factories as well, that as much as possible we want that simple singular approach to design. And so here you can see the single court was the same. This is not a single court floor plan, but it clearly identifies the sort of mate wall. In the previous slide, there were those red lines that identified the adjoining line or mate wall between 2 units or 2 modules. And here you can see how that tracks across a corridor from one side to the other, and the module is clearly identified as 2 units saddlebagging on the corridor, where the corridor is actually part of the construction that's taking place in the factory. And that corridor is really the lifeline, the meeting point between factory built work and site built work. And so there's so much critical focus through the design phases on coordinating how systems within the unit can engage and interact with the building systems, and how the corridor is sort of the conduit for that. And so factories are becoming more and more engaged in BIM coordination, clash detection, and things of those natures with site trades, MEP, and architects and engineers, just to really understand what all is going into the corridors, what's coming out of the units from the factory, and needs to sort of be coordinated within the ceilings of the corridors. So the drawings that we're seeing in 3 dimensions and color-coded, that's actually drawing by Autoball. And so we were fortunate with the Sangha Core project to have a team from Autoball that was really interested in seeing beyond the walls, beyond the limits of their own scope of work in terms of construction in the factory, and seeing how they can communicate to the site trades where points of connection will be made in the corridor from the unit, and how those systems will interact with one another as they make their way down the corridor ceiling.
Yeah, for those that are maybe hasn't lived with modular construction yet, all of your MEP connections funnel to this double-loaded corridor radius. That's one of the reasons why bathrooms and kitchens need and want to be within so many feet of that corridor wall. You're transporting on, especially waistlines, right? You have to slope to drain. You've only got the depth of that floor cavity to make that horizontal run, so that must pull everything towards the corridor. So fire sprinklers, electrical, teledata, mechanical, with the exception of exhaust fans, maybe going to the exterior wall, all of that wants to come back to this corridor. So part of the importance of doing this coordination, this next level of coordination we did with the manufacturer was we had a lot going on in our soffit space. We wanted to make sure that was going to work, get that all coordinated so that we weren't having to make changes in the field if we had not done this level of coordination in the design prior to manufacturing. It's very likely we would have had to done some rework because the penetrations, the stub outs may not have been in the ideal spot. So it was a game changer that we learned doing this process, again, earlier on as a design, before construction, before manufacturing, really getting down to this level of detail. That's one of the keys to success.
Yeah, and so this is getting into construction a little bit, but because the corridor is part of the module, and this isn't always the case with modular construction, but in our sort of typical approach to affordable housing projects, the corridor is a double-loaded corridor, and it's included within the module. The modules themselves and the units within those modules are finished on the interior, but the corridor side is left unfinished because all these connections need to be made, because connections for shear walls on the corridor line need to be made. And I think if we can go back one second, the section details on the side show how after a module is dropped into place and stacked on site, one of the first steps that the GC will do is go through and cut out the ceiling framing of the module. And that gives you a little bit of extra space and a little breathing room to make all of these coordinated kind of weaving of systems through the corridor ceiling and have, a ceiling height in the corridor that's tolerable. So here we see an example of just all the waste stacks and MEP systems that are running through or potentially running through corridor wall and need to be connected out to the corridor site systems. And it's often the case that shear walls for modules are located at the exterior wall and the corridors for access, so that the boxes can be set in place. You don't need to make hold down connections before the next box is set in place. You're not interrupting the crane set schedule. And so there's this conflict of interest between what needs to happen structurally and what needs to happen for access for making these points of connection. And you can see here is like a worst case example of where a corridor wall is just almost entirely stud bundles for shear. So another worst case example, this was one of our first, it was actually our first built modular project, in which case the layout of the buildings was not conducive to modules that included the framing of the corridor. And so we developed the modular units with an approach that's called sawbox units, where two end-to-end units are built within a single module, shipped to the site, and cut apart with a chainsaw, and then stacked individually into their respective positions. And so what that does, and we can see it here, is it allows for you to have an efficient and a speedy crane set period, but it leaves all of those units that are stacked above the ground level or the first level floating and just waiting and needing and exposed to the elements. And then you can see the tie back is just sort of flapping in the wind and 3 stories high or 4 stories high, and it's just not a pretty sight. It makes you cringe just looking at it.
Yeah, waiting for some attention.
That same project, and because we were kind of behind on developing the framing and access to those upper stories, you can see how it plays out with the overall completion of the project, where on some of the projects, these timelines are cut in half and 16 months, and really the finished corridor was probably 2 months later. It's 18 months after crane set is just going to kill the goals that we have for modular construction and schedule efficiency. But in the end, the project does look pretty nice, and you can see the ways in which the bump outs in the corridors reflect ways to conceal connections with MEP and work to the advantage of the experience of walking through the space. So this is the Tahanan project, where all studios, all double-loaded corridor, which is included in the factory scope of work, and the timeline is much different, where 6 months in you have all the systems, including low voltage and services installed in the corridor ceiling. Again, to Hanan, so I mentioned earlier, just architectural expression at the last sort of 3 feet to or less to the exterior wall of the unit. And in this case, we incorporated a design that was these sawtooth window bays. And it worked to the advantage of this project and the units. It allowed for us to focus the attention and the view from the windows, not across the street, which is a jailhouse, which is not necessarily the goal for bringing people out of homelessness, and to have them sit across the street from a jail and focus on that. So we wanted to shift the attention of those windows away from that, across the street and toward views of downtown, and this was a sort of strategy for doing that. And so worth mentioning on the next slide that we took a similar approach with sawtooth bays in our design of Sango Court. And I'm bringing it up here because we, in the process of switching from the original factory that Carolyn was talking about to Autoball, we had to make some design concessions. Not every factory has the capacity to or is willing to work with you on that sort of architectural expression. So there is complexity in the way that the sawtooth bay is framed. You have to rotate the floor and ceiling framing to do a cantilever, and Autoball is not necessarily set up to achieve those sorts of framing details. So we went back to the drawing board and simplified the facade and made it work in a way that still was quite lovely. There's Sango as it's completed.
Thanks, Jonas. And so I was just going to talk a little bit about some alternatives to kind of the typical or traditional 5-6-story podium, kind of rectangular, boxy, modular projects that have been completed in the Bay Area that probably most of you are familiar with. Just recognizing that modular can also work for different types and configurations of buildings. This is a project we're currently working on. And it's a kind of more residential scale project, 2 and 3 story kind of wood framed walk-up type buildings with traditional pitched roofs. So just wanted to point out that not every modular project has to be a 5 or 6 story kind of box. It works great and it's necessary in urban areas, but a lot of other parts of California, less dense sites, you can do stuff like this. Just as something different to consider, and just that actually, this picture on the right actually reminds me, one of the other benefits of modular is that modular is really effective when you have shorter construction seasons or non-weather impacted construction seasons, because you're doing a lot of that off-site fabrication. And it's also an effective way to build when you are building in areas that may not necessarily have a large construction labor force. So if you can move a lot of your construction off-site, that's another benefit of modular construction. I just wanted to point out that not every modular project has to be a 5-story project.
Yeah, staying on that for a second. One of the things you're seeing a lower density approach, and it works to the constraints of buildable seasons. But I think in this, there's also a way that modular can. So we're seeing these modules being set right at grade, rather than being built above a podium, which is a lot of this more urban kind of approach to our modular projects that we're doing. And setting it at grade means that so much more of the actual completed work is done in the factory. So you're seeing so much more efficiency through that. Similarly, you have the ability, because you're not constrained by sort of maximizing to the height limits of that site, you have the ability to install trusses, prefabricated trusses on the roof, and all of a sudden you're weather tight within a much shorter span of time. So some consideration there.
Yeah, these are the kind of projects for you here, the kind of the 50% or more schedule reduction, right? So much more, a greater percentage of the project is able to be built off-site than say a Type 5 podium project, for example.
Right, there's just so much more simplicity with these 2 and 3 story buildings. You're not putting in elevators, you're not putting in a lot of vertical transportation, you're not building a concrete podium. So what you're really doing is building a concrete slab on grade foundation and dropping the modules in. And you're done a lot faster.
So one of the key parts of the process when we're engaging with developers and also with local authorities is just that education process with the plan reviewers who are responsible for the site portion of the work. And so, the drawing set will be developed sort of as two parallel sets, where one is specific to factory built work and highlights the factory built work and either grays out or completely deletes the work that's done on site so that it's very focused. And that's delivered to the state HCD or a third party representative of the state HCD. In this case, we're identifying NTA as the third party plan reviewers. And simultaneously, we'll have a permit set that's focused on site built work and either grays out or some other way identifies factory built work as not part of their scope. But from an early part of design phases, we are engaging with the local authorities and talking to them about this process, getting them as familiar with the division of scope of plan review and inspections that will be expected. And it's pretty clearly identified by the state HCD, but not necessarily one that is easy to understand for local jurisdictions that are sort of set in their ways. And so we conduct meetings and presentations. We invite NTA, which is I think the third party company that we've solely worked with on modular projects, to the table, and in some cases have them make the presentation to the local authorities so that there's a direct conversation between who's responsible for what in what places and where there might be overlap, where there might be questions. Similarly, we have members of the city come out to the factory and either review the production of that particular project or some other, just to have a sense of what's happening on the assembly line and how the inspectors are conducting their work and review.
All right, Randall, pre-construction and after production.
The first things first is get out and get to know your manufacturers. This is a represented sample of many that we've come to know, done our homework with, we're still getting to know. But go out there, visit their factories, find out who they've built for recently, find out how their projects are going, where they're building. As I mentioned, they all have something a little unique that they do. They have different capabilities, what they can build, what kind of products they do, what their processes are. Definitely get out there. As I mentioned, Autoball was the manufacturer for single court. We're currently speaking with volumetric building companies for a project as well as Gurdon. Factory West obviously is right in our backyard, and Full Stack Modular is actually a structural steel, so type 1 manufacturer that we're getting to know. They're based out of Oregon. So we're still getting to know many of these manufacturers ourselves, but we've got some really good relationships. They've been tremendous partners. They're willing to share their knowledge. They're willing to make connections with other members who run on your team, but reach out. They love doing tours. Some of them might require a little bit of a trip, but it's worthwhile, particularly Autoball, Gurdon, and Nashua. We've done that in a 24-hour trip on a number of occasions because they're all just outside the Boise area, so you can get your money's worth. But definitely get to know them. They are,
BMC is in Tracy.
BBC is BBC is actually in Tracy, so they're also very close by, correct. But get to know them. They are a partner in the project. They are not like another subcontractor, right? They're going to represent 25 to 30% of the value of your hard cost for the job. You need to make sure you're selecting the right person, the right company for your project and for your company culture. Make sure your team's going to work well with them. And of course, get your contractor involved as well. Be part of that. Ultimately, that's who's going to be responsible for managing them. But I can't stress the importance enough of just getting to know these companies.
Randall, real quick. So Carolyn mentioned risk assessment and kind of some of the points that you make when you're doing risk analysis and studying a factory that you're considering their pipeline to make sure that you can have some flexibility within that. But similarly, and not mentioned here, is the number of factories that have gone under. So the factory, and this is an impression that people have of the modular construction industry, is that there's such instability. It is worth mentioning and worth talking to others in the industry about the successes of modular factories, but also the failures, so you really understand that risk as you're going in.
Yeah, that's one of the reasons when we're vetting a manufacturer for a given project, we do a full due diligence on them. We're looking at their financials, we're looking at their backlog. We want to know, are they actively building something now? A factory cannot, because Tommy was saying, they're in manufacturing, they need to stay busy. So if they don't have a lot of projects in their pipeline or huge gaps, that's usually not, it can be a concerning sign, right? They could be losing workforce during that time. They're gonna have to bring back and retrain. What's that gonna do to the schedule or the quality of the product that they may build for you, right? So we're looking at that. Again, we're talking to their current and recent clients to know how they experience were there any quality issues, with any schedule issues, how do they like to work with during pre-con. So you really want to get to know them. It's a very important decision, and they are truly a partner in the project. So choose wisely, right?
On Sango, when you guys switched from Nashua to Audubon, what was that like? What was the vetting of Audubon?
So it was interesting because Audubon wasn't, we weren't aware of them when we did the first round of interviews and selection for the project. When we talked to like National and Kurt and others, we made the first selection. And then when the financing, challenge presented itself, we went back out and always asked the conversation, what's your backlog like? How was pricing then? What would your updated proposal look like? Because some time had passed. That's when we got introduced to Audubon. So coincidentally, we were Audubon's first third-party project. Not their first as a manufacturer, because they had a development partner that they'd done most of their work for up until that point. It just called, the stars were aligned, I guess, that they were willing to, they had a slot in their factory, they were willing to now open up and entertain new relationships. And it worked out for the better. I mean, they were a tremendous partner in the project, and it's a really good experience with them.
Yeah, and I would just add that, I think it was a lot of the same kind of vetting that happened. I think looking at the financials is important, their bonding capacity was important, things like that. That had to happen pretty quickly, but, fortunately, we were able to kind of check those boxes with them as well.
Yeah, great.
And just to mention some of the other called international manufacturers that we've come to know or been introduced to outside of the US. So the two on the left, Modular Solutions and Rock Modular, those are both Canadian-based. They're wood frame manufacturers that do all the same kind of product. Whether they're competitive or not really depends on what the dollar's like, what's going on in the economy. Certain markets, I think, maybe further north, that they can be a little more competitive on. Obviously, the cost of trucking is a little more expensive. But they both build a really great product. And then on the right, Stack Modular is actually a Canadian-owned company. It's a structural steel frame product, so it's a Type 1. They're manufactured in China. So we're getting to know them as well. But again, because the popularity of modular construction is growing, you're seeing more companies coming online. We're constantly trying to find out who they are, get to know them, track them. What if an opportunity comes up where they might be a good fit? We don't want to be having that conversation for the first time. We'd like to kind of know in advance. So.
Yeah, I think it's important just for any owner, developer considering modular, just to have your eyes open and be aware of these risks. Like we just talked about, a lot of these modular manufacturers, they've done, a dozen, 2 dozen projects. It is some projects, but maybe they're 5 or 10 years old. So they don't all have, they're not 100-year companies. And so they do come and go. As an owner, you just want to have your eyes open and just be aware, what's the pitfalls. Like we talked about earlier, is there a backup plan? Is kind of go back to stick frame if you really needed to.
Mm-hmm. So continuing on with pre-construction. So one of the first things that we look at when a project gets introduced to us is it viable, right? Does this make sense to use this method? Modular is not a one size fits all, unfortunately, so it's got its place. So one of the first things we'll look at is site logistics. Do we have, what's the access like? Is it a dense urban environment? Is it somewhere where we got more space around us? Do we have overhead utility lines to contend with on either or multiple sides of the site? Craning is obviously a critical piece of the construction process with modules. We have to have a place where we can place a crane. They need a reasonable amount of real estate. So is that crane going to be on site? Is it the room to put it off site? Is there an adjacent site that we can lease? And then as well as trucking the modules to the site, we need a staging area where we can pull the trucks up. We can unwrap the modules. They're coming to us. We'll talk more in a few minutes here, but they're shrink wrapped when they arrive. We need time to unwrap the modules. We need to prep them for hoisting, get them ready to go. That all requires site access. So there are some sites that we look at, and we'll do a study and determine whether or not we think this is viable that way. And if it's not, we'll be honest with the client, say we just don't think this is a good fit. We recommend declining the project eventually. The other aspect would be is how far away can we stage the modules? You'll need an off-site staging yard more often than not if you're not coming from a local manufacturer. So look at what does that distance look like? Where are we gonna bring the modules? Well, stepping back, when they leave the factory, either A, they're gonna come to your job site, or B, you're gonna send them to a staging yard. Ideally, that staging yard wants to be maybe 5 or 10 miles from your project site if possible to get the lowest trucking costs. So we'll look at where that might be. The other aspect of the site logistics would just be, neighborhood, are they really tight streets? Can the trucks actually get to the site? Again, really dense neighborhood with narrow streets. The trucks themselves, the modules are 65 feet, so you're probably pushing 80 feet or more, from front of the truck to the back of the trailer, so they have to actually make the turns to get to the site. So if you're in a wooded area with really tight turns and stuff, not likely it's gonna be easy to get the product to the site. So those are things we have to kind of look at as kind of non-starter conversations. Other things to keep in mind during pre-construction is some of the practices we're all very accustomed to doing for conventionally built projects, but some of the nuances with modular is deferred submittals. It seems like that list on our title sheets keep growing and growing of things that are being kind of deferred to later on. Well, the reason that doesn't work for modular is that anything that is going to directly interface or directly attach to the modules, that design needs to be done because we have to incorporate that into the modeling and the shop drawings and obviously the manufacturing of the modules. If that gets left to happen as it normally would in a conventionally built project, you're getting that design information later on. Most likely it's either going to be during or after manufacturing. That's going to result in rework on site, which is, against the goal of the project here is to get the work done off site, right? So those things have to be paid attention to, whether it gets passed on back to the design team or whether it's the GC, we end up bringing on design build partners. We have to make sure we flag those things and make them more of a priority and pull them further into the design process so we can resolve those things during the primary design phase, not as a deferred. Design coordination and BIM. So we're really manufacturing the manufacturing of the process is about 100% DEs, and then they're working with us through the rest of the design process. Right about the time we get about CDs or so, we'll start actually modeling everything at that point with the manufacturer. And we're taking these to usually LOD of 400 or better, maybe because that's the level of shop drawing information the manufacturers need for them to do their operations, right? So you're bringing that BIM modeling process, that coordination again, earlier into the project's life cycle, not just before or during construction, but we're gonna start that much earlier on. That helps us flush out any potential conflicts between site and off-site. It'll help inform where all of our canvas need to be, embeds, things like that in the podium. That all comes out of this whole exercise because we actually model, obviously, the entire building, all the models, we model the corridors, as Jonah showed earlier. But that's a real key part of this process, and that level of coordination really also helps save a lot of money and manages risks. If you find this information out now during design, you can correct for it. You avoid the cost of rework or having fewer options later by something that gets discovered during construction. Looking at advanced submittals and procurement, again, supporting the process here, you're shortening your construction schedule, right? Ideally, for a job of this scale, we see usually 2 to 3 months of schedule savings. It shortens your time frame. Things are now happening earlier in your project than they're maybe used to on a conventional job. You have to pay attention to procurement. What things we now need to be purchasing and processing submittals for earlier for the site stuff. For the modular part of it, you're doing a whole set of submittals and shop drawings, again, before construction. Usually for this, like this job here, we started manufacturing shortly after the job broke ground. But prior to that, we have to support about 90 days of procurement. So you're back 3 months back from there. And then before that, you have about 1 to 2 months of submittals. So again, you're starting to do submittals and stuff much earlier on in the process. Just be aware of that, and from a design team perspective, like know you're gonna have that added workload, and at the same time, you're trying to get permits and stuff out the door for your client. So just a kind of a staffing management consideration.
And also, yeah, Carolyn.
I was just gonna say, yeah, as an owner, you have to make all your decisions up front. You know, a lot of times in construction, you might have alternates or allowances or things like that, but you can't really do that with modular. You have to make decisions, for better, for worse, on your finishes and things like that, because once, you make the decision, you start production, as soon as you're breaking ground, basically, so.
Yeah, that's a really good point, because you could, but it's not going to be advised, you have a very unhappy manufacturer, because you do not want to change something during the course of manufacturing. It's important for them to have that locked in. They're doing procurement as well for the project. They run, think about the volume of procurement they're doing within a very short period of time. So it's very coordinated. They have to have this stuff locked in so they can support your schedule and help meet their obligations to the client.
Yeah, it's probably something to think about, like, as an owner developer and a designer and a contractor, really, is that even from like a staffing perspective, like there's a ton of work that's happening early and before you start construction, as opposed to where you do a lot kind of as you're going. So, you know, you probably have to kind of plan around that too, is that a ton of the work happens before you break the ground, and that's when you need to be focusing your staff time and decision-making and things like that, and financing, all that stuff comes up front.
Carolyn, also if you can speak to just the relationship of these early procurement, early submittals, long lead items, the way that pushes things earlier in the design schedule, and the relationship of that to closing costs, because you're often kind of pushing across that threshold into the design side of the closing date.
Procurement.
Yeah.
Yeah, that's a good question. I mean, the way that we had it structured, and I think we were anticipating it even early on, was to basically, I mean, you have to pay that deposit up front. That has to happen before you have your financing committed. But the way we were trying to, because the next big chunk is procurement, which is, you know, a sizable amount of money. So we were having that structured so that basically when we closed on all our financing, that was maybe even part of the closing draw. Was that next big deposit so that they could immediately start procuring all the materials? That's a good question.
That's correct, yeah. That was right at closing.
Yeah.
And then just maybe to give more color to the financing part of it, for the actual, the billings to do with the actual manufacturing of the models, we set up an escrow account. So they did one large draw for the remaining part, right?
That's right.
The bank, that went into an escrow account.
Yeah.
And most manufacturers want maybe a 1 to 2 week billing cycle, because you're gonna consider they're doing, it takes about 2 months to manufacture a job like this. So if they wait 1 month to do a billing that's 90 days, 6 days, or 30 days to get paid, they basically produce their whole project before they would see $1 otherwise. And so they're very cautious. They're putting millions of dollars out the door in a very short order of time, right? So we did an escrow account, and we had an established billing process with oversight that allowed for billing to happen every week with them, and withdrew out of this escrow account for the project. So my last item up there, trade contract language. As a builder, you know, the industry or subcontractor community, they're still getting to know modular construction, right? It's new. There's many that have experience, and there's a lot that still don't. And for those that have probably seen a wide range of approaches and products out there to date. So we're very intentional about identifying in the scopes of work right up front. One of the first line items in the trade part of the scope is identifying this is a modular project. Like the first thing that they see, and identifying that how that affects their scope. So that's the first thing we read is, it's a modular job. This is where your work is going to interface. This is where you're not doing, and this is what you are doing. Trying to help highlight, you know, help them understand the nuances from what they see in the drawings, because within the drawings, there are graphical cues. There's obviously notes that delineate where points of offsite and offsite are happening. But not 100% detailed out, particularly with MEPs. If like MEPs, it's more like a series of notes and comments that are in there. So we're trying to be as clear as we can with the subcontracting community to help them have a better understanding, which is going to help us get better pricing. I think it's still one of the challenges in the industry is that the subcontracting community is still being conservative how they price these, because it's new, they've had mixed experiences, so they're going to kind of cover themselves. So we're trying to get that education out there so that they'll understand it better and hopefully result in some of the price savings that we get to fully realize. So we're trying to capture that in language of our subcontracts, and I think that's a really good best practice to help, again, communicate. We're also working on, going forward, we're going to build a prototype of a typical corridor section like we saw in the photos with Jonas. So we have something physical that the trades can come to and see and really understand what their points of interface are going to be. What are the conditions upon which they're going to be performing their work?
Great. And so after the contracts are signed with Randall, I just want to give a little bit of color for those who might not be very familiar with modular fabrication and production, kind of what happens in the factory, things to think about during the quality control process, and things of that nature. So, like Randall was saying, production in the factory happens pretty fast. The first module or two, it takes the fabricator a little time to kind of get up to speed on kind of what they're building and how they're building it. But as soon as they're up to speed, typically what happens is a module will go from stage to stage in a factory. There's anywhere from 15 to 20 stages. And on a given day, once they're up to speed, they will start they'll start a new module on the platform, probably 6 to 8 modules a day. And when they're really up to speed, they'll probably finish a module within 2 to 3 weeks, something like that. And it's a continuous thing, like we were talking about earlier. It's just like a factory. So once it starts, it keeps moving, and it can't stop because the next module is waiting to move along. And so that's the reason why they can't stop. So what happens is, just kind of talk through these slides, is they build the floor platforms that often comes with all the plumbing rough in, and they're really building these modules from the inside out, which is unlike regular construction where you build the walls and then you kind of fill it in. So in this case, they build the floors, the plumbing roughing in. The first thing that goes in is usually the tub, and then they build the interior walls, and then they build the exterior walls, do all their MEPF rough-ins and put in the drywall. And the last stage is they put in their cabinets, finishes, flooring, paint, things of that nature. Somewhere along that process, they're usually putting in the exterior windows, and depending on the manufacturer, they may, like in the middle photo below, they may even put in parts of the weather barrier. And after that's all done, the module's finished, and it's shrink wrapped and looks something like that typically. And so that's the typical process. This whole thing happens, say 100 modules might take 3 months. And so you can imagine how fast things are going in terms of production rate and why things can't change and can't stop when you're doing it.
So in terms of inspections in QA/QC, which we're talking about here, but plenty of the photo up, just because the work is happening that fast, inspections are being held in the factory with third-party oversight. So just like you would have inspections on a job site from the AHJ, inspecting things like, the structural connections, MEP, fire sprinkler, that's happening in this case on behalf of NTA. So over the third-party agency that's going to be doing your plan checking, they will have an inspector in the factory on a scheduled basis to oversee that. We actually also place a representative from our company in the factory during the entire manufacturing process as our eyes of QA/QC for things outside that the inspector might be looking at. But they're really there to sign off on the product when it gets to the point where it's getting shrink wrapped. If there's any punch list items, that's not something that's typically going to be done on site by the manufacturer. They'd rather do that with their resources and materials in their factory. So we have to do that inspection. They will do a prototype of this before production starts. Forgot to mention that earlier. They will do 1 to 2 modules maybe, so you can make up a complete unit. And so you want, the architect, the owner, the CM, the GC, invite the city if you need to, right? If you've got to make believers out of that, let them come and see that prototype. If there's something that they're going to see and take exception to, you want to find it out then, not after production, after modules are showing up. So we'll do that. Again, that's more of a fit and finish, not to verify your design and go make changes, just to make sure, is this what you were expecting? If there are little details that are standing out aesthetically that you don't like or not up to your spec, you do that with the prototype. And then that third-party person or our representative of the factory is making sure they're holding to that.
Yeah, I'll just mention, like if you do, pick a company that's in Idaho or Oregon, your whole team is gonna go to Idaho and Oregon to do these types of, prototype inspections or things like that, or to meet them. So just plan on that.
Yeah, just to kind of build off of that, here's just a few more slides. The first slide over in the upper left corner is just kind of the production schedule. So each one of those numbers represents a module, and you can see how many modules are active in the factory all at the same time. And so that just gives you an idea of how fast things are going. And then talking back about inspections, most of the time in the factory, that each module will come with what they call a traveler, or the little pouch that basically keeps all the inspection records. So anybody can show up there and look in that package to see what the status of the inspections are. And that one actually has a QR code, so I think there's an online version of it. You can actually look at it online as well. And that keeps track of all of, like, for example, in this project in Vallejo, it's HCD inspections, as well as the factory's own QA/QC process. But like Randall said, it's important to have additional layers of QA/QC because things are going so fast in the factory. You want to make sure everything is going right, and you want to catch as many things as you can in those mock-up units as possible to ensure things go well. Here's an example of, on the right, what the modules look like after they're all shrink wrapped, and they're typically stored outside waiting for delivery to wherever the project is. But one of the things to note about kind of these modules, like I was talking about earlier, is the modules don't stop when they're on the assembly line because the next module needs to keep going. So if there is something wrong or something got missed on a module, a lot of times they'll have to come back after the fact and they'll take care of it after they've been shrink wrapped like this. And in order to do that, they have to cut holes in the module, in the shrink wrap, in order to get back into the unit to take care of whatever was wrong or whatever had to be addressed. And in that process, you have to be really careful, and that's where this additional oversight comes in about QA/QC, is any holes in that shrink wrap. Sometimes these modules end up sitting over the winter before they get set. Any holes or breaks in the shrink wrap can eventually cause some damage and leaks. Last photo is a little bit of moisture inside a shrink wrap unit from the way they cut the opening for the shrink wrap. And so it's important at all stages before these modules are set to regularly have somebody to just review the condition of them, just to make sure nothing's going wrong. Because remember, the inside of these modules are 100% finished, and so any water that gets in is going to cause significant damage to the unit. So you want to make sure while it's stored at the factory, you're having inspections after they've been hauled, in Randall's case, to a temporary storage site. You want to make sure that protection is still in place and it's sound, because it might sit there for another month before it gets set. Anytime you're moving a module, you have a chance for damage. And so, this is a little bit different than stick frame construction in that particular aspect. So you just want to be really careful and have as many sets of eyes on these as you can, because these are basically $100,000 finished product that you have here.
I just want to add too, that if you having to finish a module offset the factory line is not the industry standard. So if your project is experiencing that, or if you're walking a particular facility or visiting a project that's happening, it's something you want to pay attention to. It could be cause for concern for the schedule of your project. It shows that something's not going well in the factory. Are they having procurement issues? Are they having some other production issues? So I just want to be clear that that's not something that is a norm to the industry, but it's someone's having a challenge, so it's worth paying attention to and maybe bringing up to see how it's getting mitigated.
Right, and that actually goes to the idea of trying to make the modules as consistent as possible, so they're repeating the same thing over and over again. If they're only building two of a module type, they're gonna have to learn how to build the next style over and over again. And that's where you start to lose some of the efficiency with modular when you have too many modules configurations. And the last thing about quality control that's a little bit different about modular construction is you still have to do window water testing. Windows leak regularly on construction projects. And modular is a little different in terms of the testing, because you actually have to do it twice. You have to do it once in the factory, and in best practice, you should actually do it again after the modules have been set in place in their final location, because during the transportation and lifting and craning process, the modules do twist and rack a little bit. They seem very robust, but they do move around a little bit. So it's very easy to have a failure of a joint or seal or gasket due to that moving process. So you water test in the factory to make sure the original installation is good. You water test again after the modules are set to make sure nothing happened during the transport process. And we've encountered problems on both ends.
Yeah, so we actually did a mock-up, when we did the mock-up module for prototypes, that's when we scheduled the actual mock-up assembly. So prior to production, again, we had the actual originally specified window. We wanted to have the manufacturer use the approved flashing products and sealants and install the window the way it was, again, per the drawings to be installed. And did that test at the factory before production. In our case, the window manufacturer that the modular manufacturer preferred to use actually was not successfully passing this water test. And so we're glad we learned that in this mock-up, not during production, not after the modules had arrived on site. And so through that, we actually changed manufacturers to our preferred vendor, redid the water test, passed, and then we had a pre-coordinated program with the design team and their consultants on which windows were going to be tested on site. That's still a common practice. So for those units that we knew were going to be water tested on site, we actually worked with the manufacturer, and on the interior of the module of those units, they actually withheld the drywall. So we could do a proper test. So if there were leaks, you could see them right away. We're waiting for it to come through the drywall, for example. So another best practice we think worked out really well. We did not have any leaks during on site after we had set the modules, when we did the testing, and then proceeded to finish up those handful of locations on site. So it's another best practice to consider.
That actually just reminds me of one more thing about windows, and everybody's heard of the supply chain issues we've had, and for certain products you still have. Windows are no different. Sometimes you have to pivot, or the manufacturer has to pivot, because their preferred window manufacturer may not be able to deliver windows on time. And so sometimes you have to consider alternate manufacturers, and that can be challenging because, again, modular production has to keep moving, and so you need to find somebody who can actually deliver when you need them, not necessarily the product you want, but somebody who can actually deliver.
All right, Randall.
All All right, so a little more about site logistics now. Assuming obviously we got past doing the initial evaluation, now we're on site. This is actually an aerial shot of the completed Sango Court project. So as mentioned, I'm going to talk about site access and on-site staging. So in the case of this project, I'm trying to zap Tommy here. So this here is actually where we staged our crane. We had a 300-ton hydraulic hauling crane, very massive piece of equipment. It's pretty cool to see on site. The modules themselves, they're heavy and they're large. They're somewhere between 40 and 50,000 pounds each, depending on how big of a module is. So you're not dealing with a light load. It's borderline critical pick every time, right? So it's a high-risk activity. We do a lot of planning that goes into that, a lot of coordination that happens. The modules themselves, this is Sango Court, so the modules were brought into the site. In this vicinity here is where they'd be unwrapped and prepared to be hoisted. We had the benefit of the site here to the south of the page and off to the right. It was actually city property that we were able to get access to and lease parts of. They gave us more room. So you don't always get to have this much site on most projects. We definitely looked at ones that have less laid out area that we could make work. This one we had the luxury of a little more room. But when we would set the modules down here, they would be unshrink wrapped. We'd get them all prepped, ready to go. We pre-attached some of the structural connections that would need to go on to help facilitate a timely install when they were flown up to the podium level. There's multiple crews involved at this point. We've got one crew that's responsible for stripping a module, getting ready to go. A second crew that's doing the prep work for the pre-installed structural connections to get ready to be flown up. A third crew doing the actual rigging. And then we have a crew up on the podium or whatever the top level we're setting modules at that's there to receive and set the modules. And another crew working out ahead of them, again, prepping structurally to receive the upcoming modules that day. So there's a lot of staff on site. We did a lot of coordination doing it. We did pole planning. If there were other trades involved, they were part of that as well. So we could really have everything mapped out. Who's doing what pieces of equipment were going to be there, what's our contingency plans for the day. Amongst those crews, it's probably about, I think maybe 14 people plus supervisors, so it's not large. They're broken down into teams of 3 and 4, but just kind of give you the idea of the activity that's happening when we're setting the modules that day. As I mentioned earlier, we had an off-site staging yard. In this case, we use the Santa Clara County Fairgrounds. It's a popular spot for anybody who has projects in the San Jose area. They've got a lot of land. The rule of thumb is usually about 1 acre for every 20 modules, assuming you have a 65-foot long module. And so we worked with them. We had that land leased in advance. So as they were being finished at the factory, they might spend a little bit of time at the factory's own staging capacity, and then they would be shipped out. And they would ship about 16 modules a week we would take delivery of. So while that's happening, we have a person on site at that staging yard at the fairgrounds. They're there to receive. They would go in and they would inspect the module, make sure nothing happened during transit. So if something did happen, we could address it right away. Make sure there's no water infiltration, things like that. We didn't have those issues, but just those are the things we were checking for. And we do periodic checks too once they were being staged. We would go in and check just to make sure nothing had happened to the modules while they were being stored. So it was a secured site. We had security off hours during that time. They did the staging yard for about 3 months, I believe, before they were removed and they were brought to the job site. Hauling of haul routes is important just because you can't just assume you're able to truck what you want and when you want. It's one thing in the logistics of getting the modules trucked from the factory all the way out to the site, because they're mostly going on highways and stuff. When you're starting out to come in more denser urban environments, you might be dealing with multiple jurisdictions that have a say on what gets trucked when. You can find out that there's times of day that you can't haul it the first thing in the morning, earlier in the afternoon. It can have a great impact on how quickly and how efficiently you can set modules. So it's something to pay attention to early on, because it could change your work hours, could change your production rates. Having a crew on site, having that crane there is expensive every day. So you want to be able to pay attention to that, make sure you're getting the most out of those days with your plan. And then with the hoisting side of it, again, talking about the size of the crane we have, just coordinating logistics. While this stuff is happening, we're very mindful of other work that's happening on site that's within the flight path, if you will, of the modules. There's a lot going on. We have a lot of safety procedures in place to make sure, we'll say we probably had 0 accidents during this whole process. Our team did a really good job. It's because they planned really well. So this is just the haul route, just trying to show the travel distance we went. We were about just 10 miles away. This is about the approximate route that they took. We ran 4 trucks every day. They pretty much ran nonstop from the fairgrounds up to the job site. We set out a goal to set an average of 8 a day because it was our first project. We averaged 10. And I think our peak was about 15 or 16 miles, 15, 16 modules when we hit our max production rate during the process.
How long did it take you total for the 102?
It was 12 days. So 12 days to get up. We did 12 days to get up. We had about I'll talk about weatherproofing here in a little bit, but we had about 2 months of work to do to get the rooftops ready to have the roofing installed. So you're doing parapets, all your punch throughs, your MEP, curbs, penthouses. And it was about a month each for each roof to actually get the roof on and installed. So you had an exposure of like 3 to 4 months all in up there before we were dried in. So this is an example of the crane logistics. Again, this is to scale, not quite to scale. It's a really big crane, so this is what we had to work with. It is massive, it's impressive to see. It takes a long time to set up. But unfortunately, these urban environments, it's not always plausible. It has like a tower crane, right? So it has a smaller footprint. We're still looking at that to see what options when that does work. I think because the modules aren't as heavy as they are, you're really limited on what you can do. But these take up a bit of a footprint. It is possible to put a crane on a podium. We've seen that done, but you need a large enough courtyard. You need a radius of like 30 or 40 feet to really be able to put a crane on a podium. But if you have a tight site, we've looked at that. We also know that it's been done. They'll actually take a crane to put the crane on the podium and you can set from there. So it's got to be worked out with structural engineer for some reshoring, but you need enough room. Like I say, you need at least a 30 to 40 foot clear turning radius in order to make that work. So these are some shots of actually the module setting process on Sango Court. One on the left is as we're just getting started. All the wood framing, you see this is on the podium level. So there's the first layer of wood framing that goes down that helps us level the podium out. The concrete crews do a really good job getting it within acceptable tolerances as it goes for concrete. We actually needed something quite tighter for the modules. So you can imagine if you're setting a box, it's a little bit off, and you start to go up your storage, you're going to get some creep happening. So we actually lasered these in. I think we were at 16 and 10 level accuracy with these most that were done, and that aided in the success of our set. The setting went really well. I think we had one module that was just through our own error that was out of alignment, like along the axis by maybe 3/8 of an inch. Everything else after that was within like an 1/8 or a quarter. So really great when we went through doing the facade work. That's within industry standards. So we had a really successful set, but a lot of that went into came out of our planning and the prep work we did on the podium level. So another shot of our project there on the left side. The right-hand side just is an example of a project being set on grade. The common practice when you're setting on grade is to set on a crawl space type foundation. Your MEP connections and things like that, drains want to come down and go out the bottom. You gotta have access to make those up. So if you're doing anything that's gonna be an on-grade type of application, townhomes, walk-ups, you're more likely gonna see like a crawl space style foundation. You're not gonna see sitting on a sidewalk grade per se.
Yeah, so I'll kind of continue that process just to kind of get everybody familiar with construction of modular projects, if you're not familiar with it. So as Randall was saying, the modules are set, whether it's on slab on grade or on top of your podium. There's typically a wood sleeper. The modules are set, and then next slide in the middle there shows a typical kind of embedded steel connection that connects your wood modules to your concrete foundations. Appreciate that. And kind of one of the nuances of module setting, especially wood framed, is as you set each module, there are some structural connections that have to be made between that module and the previously set modules. That's the image here at the right. Because as you can imagine, when the next module goes in, you no longer have access to that face of the wall anymore. And so things have to happen between each module. That's why you can only set 8 or 10 or 12 per day, because things have to happen after each module is set. So all the modules get set, but as Randall was saying, there's a lot of work to do, especially for these kind of podium type projects after the modules are all set. So on the lower image on the left, everything you see, including the white roofing membrane, the parapet walls, the braces, the penthouse in the background, that is all site-built construction. And those are all the things that take all the extra time before you can get your building weather tight. And just as a reminder, these buildings are fully finished on the inside. So if you have weather, you really, really need to think about temporary weather protection. We'll get into that a little bit further later. Middle slide in the middle just kind of shows you, or middle slide on the bottom, kind of shows you what the modules look like after they've been stacked. But as you can see, they're not really done. They have to be stitched together at their mate lines, both floor to floor as well as kind of vertical wall to wall. And in this case, they built the wall framing and left out a little bit of the wall sheathing so that the sheathing boards could go over those joints and kind of finish out the walls with assemblies. But even after all that's done, you still have to finish the building, and there's a lot of work to be done. And so that's one of the kind of things you really have to think about or remember when you're doing modular is just because you stack the modules, you are far from done. You have to set the scaffolding, build the roof, put all the exterior wall finishes in, and as you're doing that, you have to think about the temporary weather protection.
So adding to some of the photos that are up here, so all the structural connections that are happening, you're more likely going to have either a special inspector or the city inspector. You're going to coordinate with them. They're going to need to be on site during pretty much the entire set process. Because they need to be able to see and inspect all these as you go. As Tommy was saying, some of these connections are covered as you're setting the modules, so they're going to be on site as part of that process. The kind of window kind of sample here, not entirely representative of most manufacturers. These are going to be fully sheeted, at very least the ply, because most often it's part of the shear system. But also common is going to have your exterior gypsum, mostly like a dense glass product, right? There's going to be a strip on the vertical main line here, pretty narrow, probably like maybe a 6 to 8 inch wide strip. The modules themselves are going to be about 1 to 2 inches apart, but you'll have a little bit of a rip that's removed here. And part of it because you're going to put a piece of plywood in there to help structurally connect the modules together, and then you're going to put a layer of gypsum board over the top to level out your plane. And then along the horizontal band here, for the same reasons, they'll hold back the plywood, they'll hold back the gypsum to do a similar connection to the horizontal main line. When they leave the factory though, they are usually typically wrapped with a WRB. Most manufacturers will put like a TPO type product on there. They'll leave some excess material on there that we use. Actually, it's meant to be the permanent solution, but also the temporary to lap in place to help that temporary weatherization that happens. We actually for single core for 2 reasons. Well, originally it was because we had an open rain screen system, but now it's become the norm for us going forward. But because it was an open rain screen, we had to have a UV stable product. We couldn't use tie-back. This would be more for like a stucco application. So we introduced a manufacturer to a peel and stick membrane that was a UV stable product, so that what they installed at the factory was the permanent solution. The other benefit out of that being a peel and stick is that it does well with transit and with handling and with wind exposure during construction. We've seen many projects are using tie-back and it gets windy. Those are just stapled in place. They get whipped enough, they start to pull apart. It basically becomes a sacrificial membrane and you end up having to redo all it on site. The peel and stick worked, it was far superior to that. It worked really well. It was easy to seam in. You know, when we did these vertical strips and put in our plywood and our drywall to finish off these joints, all we had to do was run like an 18-inch wide roll of that same product and go straight down and horizontal. The leading edges the manufacturer had approved to see what we could put on there for the positive edge. And we had it completely dried in the building. So we were doing that shortly after the modules were being set. So vertically, we were driving pretty quickly on this project. If you want to go to the roof.
Actually, triggering one more thought about that topic is talk to your modular manufacturer early in that process about their preferred or recommended or requested WRB membranes, because each one has certain preferences about how they would like or would not like to use for various reasons.
So this is a shot of single court when we had our tent on our circus tent. As Carolyn mentioned earlier, it was not something we were anticipating we were going to have to do on the project. We did have provisions to do temporary dry-in, as we learned from the industry what others would do, which was typically to use the membrane the manufacturer gives us out of the factory. So when they come out of the factory, they have obviously the WRB on the vertical faces that are exterior wall. Horizontally on the roof of every module, they do put either a layer of an EPDM or a PVC membrane down. On the lower floors, it's actually an adhered product. It stays in place as we stack. So you have a horizontal protection layer on that module below as you go vertical. In the event we thought we might have a rain event the next day or overnight, we would take those membranes, we would overlap them and seam them in and use that as a temporary dry-in method, both on the vertical and horizontal. That method seems to work pretty well. It is pretty much a standard in the industry. All manufacturers kind of offer that detailing. When we get to the roof level, same thing again, they have 2 layers now. They have it's like a vapor barrier that's laid down, and then they have a loose layer of EPN or PVC on top. Again, same method, you could overlap those and roll them and tighten and cinch them down, and it works as a temporary. But the problem the exposure comes was when we started doing that 1 to 2 months of work on the roof to actually build the permanent work that's out there, your parapet walls, your equipment pads, your penthouses. That whole time you're incrementally peeling that roof back, you're creating penetrations, you're creating areas to trap water. That's where the real risk comes into play. At least that's the way we see it, right? Unfortunately, the industry does not have a proven way to do this yet. We've talked to folks on the East Coast, hey, what do you guys do over there? You have more extreme weather, hoping to be some magic that they have. They actually seem to do less than what we were doing here, which is surprising. So we're very aware of that. Because our schedule had shifted, we had seen what had happened. There's some pretty large losses in the Bay Area Fortune modular projects. It's kind of created a lot of concern, and it's valid concern, but it's unfortunate. So we partnered, we found a vendor out of Pennsylvania that did the shrink wrapping system. We built a temporary, basically a ridge down the long axis of every module So we had our scaffolding still up, so we used the scaffolding as part of the support system. So we did the shrink wrap kind of over this ridge, attached to the modules, and we ran a series of cables over the top of that and kind of cinched that all down. It was expensive to do, as Carolyn mentioned. It wasn't 100% foolproof. We had some cases, we had some water get in, but it was really a lot less than what we would have had. And if we had a rain event, we had staff on site 24/7, just if something were to happen, to deal with it. If water was ponding anywhere, pump it out. Everything we could possibly do, because even if we spent that money, that's far less expensive than if we had a major leak. And so it's still worth it at the end of the day. Do we want to do that in every project going forward? No. So some of the best practices we're trying to implement going forward, some of the things we're looking at, because again, this is a question that comes up in almost every conversation we have about modulars, keeping them dry, right? So one is be mindful of the amount of work that's happening on the roof deck. If there's any opportunity to move that equipment or that feature to another spot, try to do it. It shortens our duration on the roof as much as possible. Obviously, solar is very popular these days, so there's no good way to get around that, but there may be opportunities to do different mechanical systems, maybe move mechanical equipment to another place. We actually prefab offsite, not from the manufacturer, but through one of our wall panel companies, some of our amenities on the roof so they can be installed quicker. The other thing we're looking into is more of a sacrificial roof membrane. We're talking with one of our roof manufacturers right now for something that can be installed at the factory partially, very similar to what they do now, but something that we could leave in place and more permanently dry in as the module lives on site, and also have the ability to dry in any penetrations as we go with our own carpenters and laborers. So if we could do that, even with a horizontal diaphragm, we could be dried in as we go while all that other work is happening before the roof membrane goes in, and then that would stay in place. And then when we do the permanent roof construction, that would be just completely enclose all of that. So this is one idea we haven't tried it yet, we're looking into it, but encouraging others out there just to brainstorm with your peers, find what others are doing, because I think the industry definitely could use a solution here, just an engineered solution, but it doesn't exist yet.
Yeah, absolutely. I second that thought about all my experiences. Temporary weather protection is probably the topic that comes up the most because, again, these are finished modules and you need to protect them. But there isn't a consistent industry standard for how to do it. So have those conversations early. Just know you're going to have to do it. Factor in money for it in your budget because it's not going to be cheap to do it. But definitely think about those things. So I want to just kind of wrap up the kind of construction side of this thing. Reinforcing what I was talking about earlier, a lot of stuff has to happen on site after the modules are set. And these are just a few of the images. In this case, the elevator has to get installed and the elevator can't start until you have the penthouse done and you're drying in on the roof. And so there's a kind of a critical path of a lot of things happening at the same time. Your corridors have to get finished with all your MBB connections and finishes. And then last but not least, you got to finish the site after the building is done. And then that image on the lower left is a nice design by David Baker Architects. There's a kind of site-built steel and concrete stair element that kind of goes in to provide access to some of the units. And you can kind of see the finished element on the right there. None of that could be built until the modules are in place. And because of all the timing and coordination of all the connections of that kind of stair structure to the building, that took a lot of effort. And it's a really nice Corten steel element that required a lot of coordination. But the point being that you're not really done until you finish all that site construction. So modular is not that simple.
This little guy right here. So we learned this when we were doing some of our homework in the modular. Everyone was very good about telling us that you will have cracking in your drywall. It's different from each manufacturer. I mentioned earlier, every manufacturer has something a little different how they actually manufacture the modules. And as a result of that, some make a more rigid box, if you will, out of the factory. And so we do have seen a range in the extent of the cracking, but most of the time it's kind of like an airline crack. It tends to occur at a 45-degree angle on door and window openings. So knowing that it is standard, we would expect it on any project. So we put that in the budget. We have a painter and drywall go through there and just touch those up. We put a carried allowance for every unit to go in there and do that and mitigate that. But it is just FYI to happen. That's a little extreme there. I've seen some stuff worse than that too, but it is normal. So if you walk around and you see it on someone's site, and don't judge the manufacturer by that. It's kind of an industry thing. It tends to happen, I want to say, during hoisting, because these do flex, they're large and they're heavy. The rigging might not be in the exact right spot, and so they might flex a little bit, and the drywall just gives. That's all it is. So don't be afraid, but definitely put in some money for it.
All right, so Chelsea's gonna wrap us up and talk about what if modular isn't the right thing for you, for your project.
yeah, just zooming back a bit, go to the next slide. To all the options I introduced at the beginning, we spent a lot of time on volumetric modular, and there's a lot of benefits, but if it doesn't fit for your project, there are a lot of options to explore. And I think it is a little overwhelming for owners and architects, the options out there, the onus now on designers and those procuring it to understand what's available and the pros and cons. And thank you to the panelists today, I learned a lot for sure. But we can always fall back on site build. We've done this for a long time, it's always there. Panelized, kind of dipping your toe into prefab. Mass timber, kind of new and exciting and allows us to go to new heights. And modular, and you can combine different pieces of these. And we're seeing that more and more, mass timber and panelized coming out together. Some folks are starting to investigate volumetric modular with some mass timber. So we have a lot of different options, and it's exciting but also overwhelming. So definitely reach out. That's why Woodworks is here to be a resource, and I think everyone here is here to help you pick the right thing for your project. Different things work for different sites, locations, project types. So really think about your options.
This is a company local company that we're working with, Prolific Architects, called KidSwitch, and they're specializing on panelized and prefabricated components of kitchens. And so a lot of their work right now is rehab projects and kitchen remodels in larger, higher density housing projects, and it's working well. I think it's worth mentioning here just because we were speaking about components within a unit, so modular bathrooms or modular kitchens, modular aspects that are subcomponents of the unit. And I think those things, if we go to the next slide, you can see I've mentioned this is a rehab project, and so you can see how within the span of a day, you're not necessarily displacing tenants, you can get that into there, but I think this also applies to some of the things that we're imagining about the future of modular construction, new modular construction, where different components within the unit can be pre-designed, prefabricated, sort of cataloged, and so you're actually bringing this idea of pre-designed system of the unit itself, but also the subcomponents of that unit to the table as part of your modular catalog. And I think all of that benefits the delivery process, the delivery schedule, and even the potential for pre-approval with permitting and things of that nature. So I think this is worth considering as we move along.
All right, so the 7 best practices that we've come up with based on all the lessons we've discussed. So real quick, I know we're a little after 4. So doing your homework that Carolyn, Randall, actually everyone talked about, talking to others that have done it, understanding the financing risk if you're in an affordable project, picking the right team, right? The right people on the team as well. And then keeping it simple, the architectural design can't get too crazy, right? So understanding what the modular factories can produce and can allow within their catalog. Early factory coordination, so getting the factory involved early so they can be part of the decision making. Factory QC, we talked about Randall's team having a full-time person on site every day. Is key to that. The on-site coordination, when the modules are being set, certainly a best practice, and then the module protection itself with the temporary weather protection and the Tyvek, and I want to know more about that peel and stick product that you talked about. But our 7 best practices. All right. We are at the end. We'll take maybe a few questions from the audience. Jared?
So, Question for you is, it sounds like you have done a lot of coordination, including contract-wise, right? Because we've seen some projects where, as Tommy was pointing out, when you bring on the modules, there's a lot of movement, racking, move them in place, right? Sometimes there's tracking, sometimes there's leaks and all that kind of stuff. We've seen on some projects where the on-site GC starts pointing the fingers back towards the factory, and where the factory is saying, hey, that's not my responsibility. So how do you guys get that all worked out and resolved, to avoid those kind of issues?
Well, thankfully we didn't have many issues in that regard, but the chain of custody when the product leaves the factory, right? That's something that kind of maybe unique to each job depending on who's holding the trucking contract, for example, right? So in our case, the manufacturer was handling the trucking, right? So they kind of have that liability. The trucking company has the insurance on it that protects the modules as it leaves the factory, but that liability lives with the manufacturer. So we did have a case where the module was damaged during the trucking process when it arrived on site. So in that instance, it was pretty clear who was responsible when it happened. The manufacturer, worked with us to get it corrected on site in the field right away. So that was one that's a little more apparent because it wasn't something that we had done. We had just received it. When it's on site and it arrives, it's really comes down to your relationship with that manufacturer. I mean, if you're immediately going to finger pointing, maybe you don't have a partnership that you should have had with that manufacturer. If something comes up, it should be more like, hey, we've got a problem, let's come out and take a look at it together. Figure this out, because if you take time to work together and do the forensics on it, ultimately you're gonna find out what the problem is. But I think by doing finger pointing right off the bat, it's gonna set a wrong tone. So we had a great partner in Okubo. That's not the approach we would have taken with them. They actually have a crew that was on site, which I didn't mention earlier, I probably should have. They actually had a representative crew on site during the whole set process to make sure everything went well. When the modules were set, they went through every one of them just to double check doors were aligned, things were working properly. Not every manufacturer offers that, but because they have that crew and it's roaming wherever their product is being set, they're usually kind of available. So if we were to have an issue, that would be the crew they would send out and they do the study with us. We find out what the problem is. But again, I think finger pointing is happening. I don't think the right relationship was started there.
There's also, correct me if I'm wrong, there's like a punch list exercise that happens before the modules leave the factory.
That is correct. Yeah, they do testing.
Yeah.
Yeah, they do full testing in the factories. Most of them don't do water tests on pipe systems. They'll do air tests, but there is a testing protocol that happens. But to your point, or things can happen in transit, things can happen in hoisting. It is a reality. It's something to pay attention to in terms of the detailing that the manufacturer might be doing in their factory. They'll do strapping and restraints above and beyond what the industry requires, but I think because they all do their own thing, there might not be a common thread of what the industry does to secure things like that, to prevent a stiffer product, if you will. So if there is some movement during transit, it's not going to result in a failure.
Thank you.
I have a comment and a question. Sorry, I have a comment and a question. My first comment is, having been to several of the factories that you've identified here, I will say that one of the things that I'm most astonished with is, having spent a good number of hours, I've never seen anyone bending over and lifting anything heavy. And so to me, that's one of the things that is so different from actually coming to a construction site now. And you see just incredible efficiency. There's people not standing around. So that's the observation. My question is, Scandinavia has actually took a lot of the historic American innovation in this from 50 years ago. What have you learned, and that maybe goes to all of you, as you started to sort of remake an American market and an American way of thinking from the Scandinavian experience? Because this is, of course, how most homes are built in Scandinavia.
So one of the things I don't think we have mentioned Okubo and robotics at all. So that does speak to the way in which workers' conditions has changed within the factory. You're implementing a lot more either assistance to workers, or in some cases, stations are driven by robotics, solely by robotics. And so that is a factor in kind of the way that we're taking cues from Sweden and some other Scandinavian countries, the Netherlands as well, and seeing how their delivery method and their sort of turnaround is working well to their advantage. They have a slightly different scale and density that they're working with, and I think there's a lot more ones and twos and walk-up styles, and that's different than the majority of the work we've been discussing here today, but there are lots of lessons that we can take from what they've developed.
Yeah, I agree. I think there's a lot. The European market, been doing this longer than we have, and much more advanced it. There's more of a market for it, acceptance of it, I think, as a product, both for single family and multifamily. I think one thing I would like to see in the industry is more broader adoption of manufacturing practices in the factory. So since you've been to as many as you likely have, you'll see the difference of some that are doing, it doesn't have to be the full robotics of automotive. Everything everybody gets excited about it is pretty cool. There's a lot about automotive that's even greater than that sets them apart. But they are doing more manufacturing. It looks like a factory. You go in there, if you visit BBC and Tracy, you know, in the robotics, but they have a lot more automation, a lot more sophisticated equipment. It looks and feels like a factory. There are others you go that might build a really great product, but they start to feel more like construction in a warehouse. Like it's an improvement, but you're seeing others that are moving past that, and I'm kind of excited to see where the industry can go in the future with adopting more of those sophisticated practices. And I think one, it's going to create greater workplaces for people to be in, but I think it's going to help create better products at the end of the day.
We are working at perhaps a slight disadvantage from what we're seeing from Sweden, in part because they went through a housing crisis decades ago, and the government responded and created possibilities for factories to kind of grow up, supported those factories, supported the work they were doing, and so now they're seeing the benefits of those. We're not quite there.
Is that question
Hi, Carlos Castellanos, called the Housing. And I have a clarifying question and then maybe a follow-up to that. First, for Carolyn, the clarifying question. You mentioned Sango Court had large families. So is it a large family development with 25% 2 and 3 bedroom units?
No, it was mostly ones and twos, but some 3 bedrooms, some studios, yeah.
Okay, so the follow-up question is, because that's what I've heard is one of the difficulties. I think it was even sort of alluded to amongst the panel about the more different types you have, the more complicated it gets. So how, maybe this is a little bit to you, Jonas, like how do you go about doing a 3 bedroom type? I mean, you showed a 2 bedroom there next to a 1. Is it like, how do you do that? Does it create complexity?
And how to do it efficiently.
Yeah, not necessarily complexity. It just adds a new type that the factory will need to program for, kind of reset their stations to adjust to a different layout. So it's a new, unique modular type. And so it's just, that's the inefficiency there. That you have more types, the less efficient the factory can be in their delivery.
I think on one end of the scale is if you do a studio and it's all studios, you can realistically build one product type and you build it, 40, 50, 60 times, right? That's at the optimal end of the efficiency scale. And anything you do beyond that just starts to lose some of that efficiency. It doesn't mean it's not a cost-effective product, but I think the message, the takeaway should be, if you have a multi-family product and you want to have studios 1s, 2s, and 3s, have a standardized layout for each of them. Don't have 3 variations of the 2s and multiple variations of the 3s. That's when you start to lose the inefficiencies in the factory. The scale of the project helps. If you have a job like ours that's around 100 units, give or take, you can afford to have that variety in there. I mean, I think even we had a mix even within ours because it was already designed to a point where we brought Automall on, but we had a mix of variations on a couple of units. It could have been, at the end of the year being longer or whatnot, or it could be an end condition. But if you can start from the very beginning and work with some of those standards, and you work with your architect or work with the manufacturer for recommendations on some standards to work with, and try to play with the massing earlier on to see if that makes sense, you can still build a very efficient product. You just don't want to have like variations of each type. I think that would be my recommendation.
Thank you.
We'll take one more.
I'm curious on the interface, if there is one, between the sort of reuse of, let's say, office buildings that are rapidly becoming obsolete and modular construction. And do you know of a project, or have you thought about that at all, like essentially using the framework of the structural framework as a frame for modular infill?
Not yet, but I would suggest considering prefabricated bathrooms in kitchens. There is a market for that, there's some manufacturers. They're really designed for optimally for like a type 1 type of a product where you've got, which most office buildings probably are, where you've got this open plate height. If you're at least being able to pull off some or all of your skin to an access point, again, these are like a module that we showed today. They're completely finished off on the inside, all the rough and finish MBKs are done, but on the outside it's kind of the exposed framing and points of connection. So you could take a product like that and it's, using a crane, it's slid from the outside and with some light duty equipment, it's able to be moved into position and then connect to your on-site plumbing. You could build around it. So you could get some efficiencies to get a large enough project using that. And again, having maybe 1 or 2 different bathroom types. That's one way you could use prefab with the existing building, I'd say.
All right, let's give a round of applause to our